at the equator. So far, we've read and discussed just general information about hurricanes, when and where hurricanes develop, and then that time period of the year in which they develop and why they develop during those times. Today, we're going to get into the Coriolis force and how that is a major contributor to how hurricanes develop. I'm going to read through the passage, a couple paragraphs there, and then we'll move on to respond to parts A and B. Make sure you follow along as I read. Even though hurricanes form over waters near the equator, they do not develop at the equator itself. This is due to the Coriolis force, the apparent shift of a moving object produced by the rotation of Earth. Because Earth rotates from west to east, wind in the northern hemisphere appears to curve to the right. In the southern hemisphere, wind appears to curve to the left. The wind itself does not actually change directions. However, instead, it is Earth that moves beneath it. The Coriolis force creates the spin of a hurricane. In the northern hemisphere, hurricanes rotate counterclockwise, while in the southern hemisphere they rotate clockwise. The Coriolis force is strongest at the poles, gets weaker with decreasing latitude, and is absent at the equator. Without the Coriolis force, the air will not rotate and a storm cannot develop. So we have two diagrams here. We have northern hemisphere diagram, we have a southern hemisphere diagram. Shows how the hurricane rotates and in which way the wind will curve. So part A, if you were in an airplane flying from Miami, Florida to Toronto, Canada, would the plane drift to the right or left as it flew? Well, you're going from south to north, okay? So you're going into, we're in the northern hemisphere, all right? So if you look at that diagram on the northern hemisphere, it shows you which way the hurricane rotates and which way the wind will curve. So the northern hemisphere should clue you in for number one. The wind is going to curve to the right, so the plane would drift to the right as it flew. Number two, if you were on a ship sailing from Cape Town, South Africa to Rio de Janeiro, Brazil, would the ship drift to the right or left as it sailed? Well, those locations are in the southern hemisphere. So if we look at the diagram for the southern hemisphere, it's going to tell us which way the wind is going to curve and in which direction. So it's going to curve to the left, so that ship would also drift to the left. Part B, in your own words, explain why the Coriolis force must be present in order for a hurricane to form. Well, without it, the air doesn't rotate, the storm can't develop. There you have it. Science Bell Work, week 15, day 4. Hope you followed along and made corrections if you need to. And have a good day, guys.